Okay, so here we are with the penultimate chapter in the book. This is item reduction and reducing attributes. And basically, the focus of this chapter is what it says on the tin. We want to reduce what's in a view, and it's a major strategy that we have for managing complexity within a visualization. So as you've kind of come to expect, Munzner always starts out with the big picture, and basically reduction helps us to manage complexity because we're reducing the number of items or reducing the number of attributes. And there are two major strategies, and we'll cover those in a few slides. Those are filter, which eliminates elements or attributes, and aggregates, which combines the elements or attributes into new ones. Of course, the devil's in the details, and there's a challenge to minimize data that's shown while keeping its salient features. The definition on the slide gives a fairly good differentiation between filtering and aggregation, but let's take a look at the pros and cons of each approach on the coming slides. So filtering, the good thing about filtering is it's easy to understand and it's pretty easy to implement. We're just removing elements. The difficulty is people can forget the elements that have been removed. You may have forgotten about the coffee grounds that were in your filter. Aggregation is safer cognitively since you have a stand-in for the original, although they're combined. And not all of the omitted information is conveyed, even though you still have some access to that. So filtering can be accomplished by allowing the user to select one or more ranges to leave out. For example, we can have the user type the minimum and maximum for a range and exclude the rest. Now, the good news is this is pretty easy to program. The problem is it's a bit hard to use. How do you know which numbers to type? A lot of websites support filtering. For example, if we're shopping for some shoes today and we just want to pick out the ones that were on sale in men's size 10, we can do that. Let's take a look at an example of this. Something we might do is if we have to go over to Oahu, we might have to purchase a hotel. And one solution to this filtering is to use dynamic queries. These are tools such as sliders or checkbox that you may have seen on sites such as Kayak. I believe Doc Martin's website has them as well. And what they have is they have scented widgets. So when you look at the freebies, such as free breakfast, you'll see 13 hotels will have free breakfast. There are only 3 with a free airport shuttle. You probably don't want to stay at any of the hotels that offer free airport shuttles on Oahu because they're not the greatest hotels and they're pretty far away from anything or any place that you really want to be. Filtering attributes, this allows us to filter the attributes instead of the items so we can remove some attributes. So here we have examples of medical records and we're removing some of the attributes that we're not interested in. This is from the DOFSA approach, which stands for Dimensional Ordering, Spacing, and Filtering approach. Part A, we see glyphs representing 215 dimensions and 298 points. That's a bit too complex for us to understand, and we can't see the structure of the patterns. In figure B, we order by symmetry and filter by similarity and importance thresholds. And then we can actually begin to see some structure here and how these are similar in terms of the structure of the medical records. Aggregation is grouping elements together by a new derived element that stands in for the entire group. And there are 5 basic operations for this. There are some more advanced ones. The 5 basic operations you probably have seen in some of your introductory data science courses. One is average, usually the mean average, although you could go with the median or the mode as a measure of central tendency. There's the minimum, the maximum, the count, and the sum. And the little cartoon here says, the teacher says 500 words on Pascal's triangle by Friday, and Theta says you're a mean teacher. So it's a kind of what you get with statistical cartoons, and that's about as good as you get. Another way to do this is histograms, and these are an example of aggregation. Here we put the items into bins and show their distribution. And these are the cats by their various weight class, and at least one of these cats is an absolute unit. Another technique for this aggregation is continuous scatter plots. basically use color coding in each pixel to indicate the density of overplotting, and this eliminates problems with occlusion when you have the 3D thing. Like here's a scatter plot of a tornado airflow, and you can see the airflow without being occluded from portions of it. Another technique is box and whisker plots, and they show an aggregation of statistical summary data for all values that occur within a distribution of a single quantitative attribute. So the vast majority of things are going to fall within those boxes. The thick black line there is the mean for them, and the whiskers extend out of the core box to show where things can lie within a standard deviation or two from the box, and then the outliers are shown explicitly so we can see where they're at. And this allows us to see a large number of data points in a relatively small visualization. Spatial aggregation is another way to do things, and this goes to a problem called the modifiable areal unit problem. And errors that are created when variably grouping data into artificial units for analysis, such as, we might have with political divisions within districts in a political area. And the modifiable areal unit problem is a challenge that occurs during spatial analysis of aggregated data, in which the results differ when the same analysis is applied to different data, but we use different aggregation schemes. And so we create different zones and zoning lines, and we get very different results. In A, a lot of the population is near the center of the geographical unit. In B, it's of medium density, and of C, it's low density. So an application of this is used by our politicians for great political effects, and that's changing district boundaries for political advantage. And there are different ways of doing this. So cracking is diluting the power of the opposing party across districts. Packing is the opposing party is kept in one district. You see that a lot. And homogenization means the minority party can't win any district. So, if you're the majority party, you're getting the majority of the votes, such as yellow. You can divide it up so that yellow wins all the districts because they're 60% of the population. So that's an example in the upper left. And this is a term called gerrymandering, and there are 22 different examples, at least last time I looked, in Wikipedia, where they had examples of gerrymandering. So that's the modifiable areal unit problem, or political application is gerrymandering. Attributes can also be aggregated, so we can take attributes and synthesize them to take the place of multiple attributes. Very simple approach is to group them by some type of similarity measure and then synthesize the new attribute by calculating an average across that similar set. More complex approach is to aggregate is dimensionality reduction, where the goal is to preserve the meaningful structure of the data set while using fewer attributes to represent the items. And that's a bit of an abstract slide, so let's take a look at a concrete example. For example, a bag of words. So text documents can be transformed by ignoring explicit linear ordering of the words within the document and treating it as a bag of words. Number of times that each word is used in the document is simply counted. The result is a large feature vector where the elements in the vector are all of the words in the entire document collection. So let's take a look at an example, and these are a couple State of the Union addresses, and we can see similar structure between them. You get a lot of America, you get a lot of world, will, states, country, years, can, and now appears quite frequently in them. They're they're kind of similar in structure. You can see differences of them. The one on the left is Obama's last State of the Union, and the one on the right is Trump's latest State of the Union speech. So, they're kind of similar, but a bit different in terms of the words that were used by the two different presidents. You can also take the bag of words and perform something called sentiment analysis, which is analyzing large amounts of text for sentiment. It can either be, words can either have positive or negative connotations. A good introductory data science exercise is to analyze Shakespeare's plays for sentiment. Here we can see Romeo and Juliet, and it starts out on kind of a downer, gets a little, more happy, and then it turns into a major downer. Romeo and Juliet is not a love story. It's a 3-day relationship between a 13-year-old and a 17-year-old that caused 6 deaths. Sincerely, everyone who actually read it. And remember, it's a tragedy versus a romance. Oh, happy day. And some final thoughts, and these are from Munzner, and she puts them at the end of the text. In dimensional reduction, only relative distances matter. Use inspection to find and verify large-scale cluster structure. And 3D scatter plots are really hard to read, of course. 3D causes more problems than it takes care of a lot of times in visualization. And finally, Jerry Springer would like you to know to take care of yourself and each other. Thanks for listening.